Hello and welcome. Dr. Andy Rosenfarb here. Today we're going to have another really important conversation. This is the fifth factor that can accelerate progressive vision loss. So if you've been following our content, you know that for a really long time, probably the last 10 years or so, we've been talking about the top three factors that can accelerate progressive vision loss. Those are primarily blood flow, circulation, hypoxia, right? We need good blood flow to the eyes and good oxygenation, good food supply. That's the first factor. The second factor is inflammation. And we went very, very deep into what causes inflammation and how to manage it. The third factor, which we spent a lot of time over this summer talking about, is oxidative stress, reactive oxygen species, and free radical damage and how that affect your vision and what are some of the best ways to help manage that. Then last week, we talked about cell stress and how that can impact your cells and your function and your vision, what to do about it. Now, this fifth and final factor, these last two factors we added fairly recently, is mitochondrial dysfunction and cellular fatigue. So specifically ophthalmic mitochondrial dysfunction, which are going to be specific to the mitochondria dealing with the ophthalmic function of the body. So today we're going to talk about two things. The first, we're going to talk about what is ophthalmic mitochondrial dysfunction and eye cell fatigue, and we're going to talk about how it affects your vision. The next video that we're going to do for you guys is going to talk about how to deal with it, supplements, treatments, and stuff like that. So I'm breaking this up into two parts, primarily just because of time. So I really want to focus this time on what it is, and then the next section will help you guys understand what you can do about it. So let's start with that. What is ophthalmic mitochondrial dysfunction? Call it OMD, and cell fatigue. So again, this is another extremely relevant topic when it comes to progressive vision loss. It's a big piece of the puzzle that no one's really talking about, just like oxidative stress, cell fatigue, some discussions about inflammation and blood flow, but not even that much. So this is another area that we want to cover. It's very, very important that you guys understand this. Nobody's really talking about it, so here we are. You guys really, this is need to know information for you guys. Some of it gets a little bit deep into biology, but I'm going to do my best to try to simplify it for you guys and slow it down and break it down so you can understand it. If you have any questions about this or anything's not clear, please feel free to reach out or comment. If you're watching this inside one of our Facebook groups, you can add comments, ask questions. It will also be posted in our YouTube page, and you'll probably be receiving an email if you're a subscriber to our email list on this. So again, feel free to reach out if you have questions around this, and you can even comment below. And for sure, I'll get back to you on that. I'll respond to your questions. So what is mitochondrial dysfunction? Mitochondrial dysfunction refers to a state in which the mitochondria, which are the energy-producing organelles inside of our cells, simply aren't functioning properly. So the mitochondria, as you might remember from 7th grade biology class, are often referred to as the powerhouses of the cells because they generate what's called adenosine triphosphate, ATP, right? This is a primary source of energy used by cells to carry out various functions. In Chinese medicine, we call this qi. Or in Japan and Korea, they call it ki. This is the life force energy talked about in acupuncture and Chinese medicine, Ayurvedic medicine, traditional Japanese medicine, and Korean medicine. A lot of the East Asian traditional medicines, even in Ayurvedic medicine, they talk about the prana, right? That is the vital life breath. So it's this whole idea. ATP is more of a modern interpretation where we're able to quantify and really figure out what this substance was. So it's this ATP energy. So mitochondria, of course, are involved in many essential cellular processes beyond energy production, including things like metabolism regulation, cell signaling, and also overall cell maintenance, just maintaining their health and function. So that's important to understand there. The mitochondrial dysfunction can occur due to a variety of factors, including genetic mutations, environmental stress factors, epigenetics, toxins, disease, viruses, microbes, bacteria, metabolic stress, radiation stress, so on and so forth, and also age-related changes. So when the mitochondria are not functioning optimally, it can lead to a range of ocular cell problems and contribute to the development and progression of various eye diseases and ophthalmic conditions. So I want to discuss now, here are some of the factors that can contribute to ophthalmic mitochondrial dysfunction. So this is a quick list, and I just want you guys to understand. Some of them, again, are a little bit biological, so I'll break them down. And if you want to take a note and kind of Google them, or go wherever and try to learn more about that, you're welcome to do so, and/or ask questions. So the first common factor that can contribute to ophthalmic mitochondrial dysfunction and cell fatigue are genetic mutations. All right, mutations in genes responsible for coding mitochondrial proteins or controlling mitochondrial function. These can lead to dysfunctional mitochondria. So these mutations can be inherited, or they can be acquired over time. So these mutations can really screw up the body's ability, or specifically the mitochondria's ability, to produce energy. So that's the first one. The second one is, of course, oxidative stress. We've been talking a lot about this over the last couple weeks. And the mitochondria do produce reactive oxygen species as a byproduct of energy production. Again, the ATP energy production. Under normal circumstances, cells have a defense mechanism to neutralize these harmful ROS species. However, the excessive ROS production, reactive oxygen species, or a compromised antioxidants defense system, meaning you don't have a lot of antioxidants in your body to manage this, can lead to oxidative stress, which is overabundance of free radicals in your body, systemically or locally in your tissue like your eyes. So again, that could damage the retinal and optic nerve mitochondrial components and ultimately impair vision and accelerate progressive vision loss. So oxidative stress is, of course, a really, really big deal. We'll be talking a lot about that. We'll continue to talk about that because that's something that we really need to help you guys manage. Another factor that can contribute to the cell fatigue is impaired oxidative phosphorylation. All right, that's kind of a wordy thing, but what it really means there is oxidative phosphorylation is a process by which the mitochondria generate ATP energy. That's how the mitochondria produce energy, chi, energy, ATP. If any of the components involved in this process are dysfunctional, the ATP energy production can be reduced, all right? And we're gonna have subsequent cell fatigue or low energy production, and we're gonna have basically cellular dysfunction as a result of that fatigue or lack of production of ATP. So the fourth factor is mitochondrial dynamics, all right? So again, this gets really sciencey, so I wanna keep this kind of simple. Mitochondria continuously undergo a process of fusion and fission, all right? A lot of you guys who kind of geek out on nuclear energy and stuff like that, if you watch Back to the Future and stuff like that they talked a lot about fission and stuff like that. So basically fusion is the splitting of the nucleus, and fission is the combining of two nucleus. And this is how the mitochondrial maintain a healthy, functional system by releasing vast amount of energy. So this fission-fusion process that the mitochondria undergo by is really a very high way or a high mechanism by which the body produces ATP energy. Imbalances in this process can lead to the accumulation of damaged mitochondria and subsequent cellular fatigue. So these cells are going to start to shut down, they're going to grow weaker, and it's going to create a chain reaction where the mitochondria are just not having this explosive amount of ATP energy that's required for function, right? Basically, we're talking about it's a conversation of functionality. So the fifth factor is calcium dysregulation. Calcium dysregulation is very, very important. The mitochondria are also involved in this process of regulating calcium levels within the cells of our eyes. Dysregulation of calcium homeostasis can disrupt mitochondrial function of our ocular cell signaling. So calcium dysregulation has a lot to do with cell signaling. Very, very important process. And when we have mitochondrial dysfunction or low energy output, this dysregulation or cell signaling can really trip up the system and just cause a miscommunication and a dysregulation of function. So it's two more, guys, hang with me. The sixth is defective mitochondrial biogenesis. Ooh, sounds very serious. So this is pretty simple. It has a fancy name, but it really means where the cells rely on the process of this mitochondrial biogenesis to produce new mitochondria, right? This is the production, the way by which the body produces more mitochondria, generates these new organelles to continue the energy production, the ATP energy production. So disruptions in this process, of course, can lead to a decreased number of functional mitochondria and ultimately a lower ATP energy output. So this biogenesis or production of these cells, specifically the organelles, the mitochondria are again an organelle inside the cells, is just going to result in a lack of energy production in the body, lack of chi, lack of ATP energy. So last here is mitochondrial DNA mutations. Now, this is interesting. You guys may not be aware of this, but the mitochondria actually have their own DNA separate from the cell's nuclear DNA, right? So the cells we know have their nuclear, inside the nucleus and nucleolus, each cells have their own DNA, but the mitochondria have its own DNA. Very, very interesting. And the mutations of the mitochondrial DNA can affect mitochondrial function, of course. And the mitochondrial disorders can often involve mutations of these genes. All right, again, a little wordy there, a little sciencey, but it's important for you guys to just understand that. And feel free to ask more questions about that. I don't want to spend too much time on that because I want to get more to the vision stuff and what's applicable for you guys to understand how this can impact your vision. So before moving on, I just want to note that mitochondrial dysfunction has been linked to a wide range of not just ocular issues, but a whole host of systemic conditions, all right, including things like, of course, progressive and degenerative vision loss, neurodegenerative vision loss like Parkinson's, Alzheimer's, dementia, ALS, stuff like that, cardiovascular diseases, stroke, heart attack, obvious cardiovascular disease, hypertension, also metabolic or disorders like diabetes. Autoimmune disease is huge, right? Huge player in autoimmune disease is mitochondrial dysfunction, and certainly different types of cancer can be a factor with mitochondrial dysfunction. Additionally, mitochondrial dysfunction is very implicated with accelerated aging. So when there's mitochondrial dysfunction, we're going to see more oxidative stress. We're going to see the appearance of accelerated aging, whether it's on an organ level or with the eyes, right? We talk about a lot of these eye conditions like that are specifically age-related, like macular degeneration, that are a result of accelerated aging from oxidative stress, from mitochondrial dysfunction, from dehydration, from inflammation, poor blood flow, so on and so forth. So because the mitochondria are involved in so many vital cellular processes, addressing mitochondrial dysfunction, is very complex, and it's very important. So research into understanding the underlying mechanisms that we've done to help restore this ocular mitochondrial dysfunction really holds a lot of promise for both the recovery and long-term preservation of your vision, which leads me into the second half of this conversation. And the obvious next question that most of you might have is, how does mitochondrial dysfunction contribute to your progressive vision loss? How does it cause or contribute to your stabilization of your eye condition? Or if it's not handled, how can it cause an acceleration of your progressive vision loss? And or these factors can also give rise to acute vision loss conditions, retinal bleeds, hemorrhages, ocular strokes, infections, spontaneous autoimmune conditions, so on and so forth. So let's talk a little bit more about that. So again, the mitochondria dysfunction can contribute to progressive vision loss through several mechanisms, all right, that'll affect the health and overall function of the retina and the optic nerve. So again, mitochondria are these energy-producing organelles within the cells. When they don't function properly, it can really lead to a variety of ocular issues that relate to our vision. So I'm going to give you guys a list of about 7 or 8 different mitochondrial dysfunction factors, all right, these are the how and why it can affect your vision. So these are really important to understand. So I'm going to slow down a little bit just to take time. Some of them we've gone over, but some of these are going to be really, really brand new to you. So we'll help understand these. So we already covered there's going to be the first factor is there's going to be an overall energy deficiency, right? We talked about a cell fatigue, a weakness, just like an exhaustion. You guys know how it feels when you don't have your energy. Maybe you haven't slept, maybe you're overworked, maybe you're recovering from some type of injury, or maybe you just like ran a marathon or did some type of, intensive physical thing, or even giving birth, or, again, coming off COVID, for example, which is kind of more relevant. Your body's just tired. Well, the cells can have the same experience and undergo some energy insufficiencies or fatigue. So the mitochondria play a crucial role in producing ATP, of course, which is the primary energy source of the retinal cells, the optic nerve cells, and the whole visual system. The retina and optic nerve require significant amounts of energy to function properly. We talked about that with the retina being the highest oxygen-consuming tissue in the whole body. The reason that is because of the need for mitochondrial function, right? Oxygen is required for the cells to undergo the mitochondrial function to produce energy. The mitochondria cannot work well and cannot produce energy without oxygen. Okay, so there's a very good link there, very close link there. Mitochondrial dysfunction can lead to decreased ATP production as a result of low oxygen, or we're going to talk about some of the other factors that will drive it. And energy deficiency can impair the ocular cells for maintaining healthy and proper vision. So it's this overall fatigue and lack of energy, lack of metabolic activity, lack of detoxification processes. So it's a slow metabolism. That's really what ultimately happens here. So the second is, after energy deficiencies, or oxidative stress. Again, we keep talking about this, but it's very relevant. And how does it relate to mitochondrial dysfunction? Well, let's look at that. The mitochondrial dysfunction can lead to overproduction of reactive oxygen species, right? Free radicals, also known as oxidative stress, when these free radicals accumulate in the body. The ROS, or free radicals, can be harmful when they become excessive in the body, and can damage the cellular components, including the lipids, the proteins, and even the DNA, right? So a lot of these genetic eye conditions we've talked about before can be the result of things like oxidative stress, mitochondrial dysfunction, certainly toxicity, stress. Any of these epigenetic factors can really affect the DNA part of the cells, and oxidative stress in the retinal cells and the optic nerve can lead to inflammation, cell death, structural damage, all contributing to progressive vision loss. So that's the second one, oxidative stress. We've talked a lot about that. So if you guys are interested in learning more about this and this is your first time watching, go back and watch some of the videos on oxidative stress. We probably have about a half a dozen specifically or more on oxidative stress and why it's such a significant issue for you guys to understand and how it relates to your vision loss. Okay. Number 3, this is new for a lot of you guys. We're going to dive a little bit more into this topic over the next couple weeks. It's called apoptosis. Okay, this is programmed cell death. Mitochondrial dysfunction can trigger this process of apoptosis, which is programmed cell death. When the cells in the retina and optic nerve undergo apoptosis, it can lead to loss of impairment of cells involved, obviously, in this case, in the ocular system. It can lead to such photoreceptors, things like photoreceptor death, the rods in the cells can die in the retina, or the retinal ganglion cells, and the optic nerve, and even the brain, right, the whole visual system. So if we have an optic apoptosis, I don't want to get too into it right now, but it is a healthy process. The body needs to have this process of killing sick, damaged, or mutated cells in order to replace them with healthy functional cells. So this is an important process, again, that we're going to get into, but if it's hyperactive and there is more cells dying, there's a hyperactivity of apoptosis or programmed cell death, basically meaning the cells are breaking down faster than they can be rebuilt or regenerated, then we're going to have progressive vision loss, because there's obviously going to be some loss there. So that should make sense, right? So, okay, let's move on to number 4. The fourth way that this mitochondrial dysfunction can impact your vision negatively is through impaired mitochondrial dynamics. Again, we talked a little bit about proper mitochondrial dysfunction relying on a balance between fusion and fission, right? Joining of the mitochondria and splitting of the mitochondria. Mitochondrial dynamics play a role in maintaining health and function, specifically retinal, optic nerve, and the whole ocular system. Dysregulation of these processes due to mitochondrial dysfunction can lead to accumulated damage, which can disrupt overall cellular process, specifically when it comes to the central nervous system, the brain, the eyes, the optic nerve, and the retina. So it's just, again, this ability for the energy to have the ability of the cells, rather than mitochondria, to have these bursts of energy production. It's just you're not producing enough energy, which is going to result in a fatigue where the metabolism is going to be compromised, the respiratory cellular respiration is going to be impaired, and ultimately we're going to have detox. The detox pathways are going to be impaired. We're going to have increase of cellular waste products, which is no bueno. Okay, so moving on, the fifth factor that can affect your vision when it comes to mitochondrial dysfunction is impaired calcium regulation, all right? So the mitochondria are also involved, we talked a little bit earlier about this as well, in terms of regulating calcium levels within the cells, specifically the eye cells, ophthalmic, the whole visual system. So calcium is a critical signaling molecules we talked about earlier for the visual system. Mitochondrial dysfunction can lead to disturbances in this calcium homeostasis, which can affect and lead to damage and death and dormancy of these cells, the retinal cells, the photoreceptors, the optic nerve, and the brain. So we talk about why do cells go dormant, right? Why do they get damaged, and why do they get sick, and why can they ultimately die? A lot of that has to do with the signaling in the calcium dysregulation. So we don't have this calcium signaling, and that improper signaling, again, will lead to cell death, damage, and dormancy. So the sixth and second to last factor is genetic mutations. All right, this is quite interesting. So mitochondrial dysfunction can rise from genetic mutations, right? Throughout our lives, we have epigenetic stress factors that can cause gene mutations, which can, of course, affect gene signaling and ultimately gene expression. The mutations in the mitochondria or nuclear DNA affecting mitochondrial function, inherited mitochondrial disorders such as Leber's, RP, Usher's, Stargardt's, any of these genetic conditions can cause progressive vision loss due to specific mutations affecting the optic nerve's retinal ganglion cells. So these genetic mutations really go after the ganglion cells, and of course will impact this mitochondrial process. So a lot of these conditions, this is really, really important for you guys with like RP, Usher syndrome, any of the retinal or optic nerve, even optic nerve atrophy, some of the autoimmune and genetic cases of glaucoma, which we see quite often. Really, really important to understand that the genetic mutations can dramatically affect the nucleus and the genetic code of the mitochondria, disrupting it, so that we have, again, this deficiency of cellular respiration, cellular metabolism, toxic accumulation, again, in things like retinitis pigmentosa and Usher's, and even Stargardt's. We see an accumulation of pigmentation in the eyes. When we look more at things like macular degeneration, we see an accumulation of drusen, ocular waste products. On the optic nerve, we can even see optic nerve drusen, which is not as common. We see that a lot as well. So these genetic mutations can really have a big impact on the mitochondrial dysfunction, which again will, as they progressively become more dysfunctional, that will lead to progressive and/or accelerated vision loss. We stabilize this and improve mitochondrial function, then we're going to stabilize your vision, right? So it's really, really important to help improve cellular mitochondrial function in order to help preserve your vision. So the last thing we're going to talk about is optic nerve damage. Mitochondrial dysfunction in the retinal ganglion cells of the optic nerve can lead to degeneration and damage of the optic nerve fibers. This can result in optic nerve atrophy, optic neuritis, glaucoma. Again, we just talked about optic nerve drusen, and result in impaired transmission of the visual information from the eye to the brain, right? So we're not getting a clean signal. So that's, of course, going to impact our vision. So collectively, these efforts of the mitochondrial dysfunction can lead to a gradual decline in vision, especially in conditions, of course, macular degeneration, retinitis pigmentosa, Usher's, Stargardt's, glaucoma, optic nerve issues like optic neuritis, optic nerve atrophy, certainly eye strokes. We can have acute conditions like eye strokes, retinal occlusions, bleeds, eye strokes, even things like diabetic retinopathy. Of course, we talked about the effect on cellular metabolism and respiration. So there's problems that can arise there as well. So understanding these mechanisms is crucial for the developed treatments that we've created and interventions that target mitochondrial health to slow down the progression of your vision loss. So let's summarize this real quick. So that's where I kind of want to stop there and just let's recap a little bit. So we have this process, right? We have this process called mitochondrial function, right? Functionality. It's where the body produces energy throughout our whole body, right? This is how we uptake our energy. When those processes become deficient, they're impaired, it's just not working optimally anymore. Early on, we're not going to see a lot of symptoms, but over time, we're going to see some problems, right? Whether it's in your heart, you're going to get a heart attack. We could see things on the cardiovascular system. We could see the immune system. The immune system can start to break down. We get things like allergies or autoimmune conditions. If it really breaks down the immune system, things like cancer can arise. We for sure see it with conditions of cognitive or brain neurodegenerative conditions, ALS, Parkinson's, Alzheimer's, dementia, so on and so forth, which are very closely related to a lot of these conditions. Neurodegeneration is neurodegeneration. So we are looking at a lot of these similar processes to help overall health, right? And it's very, very important that we do that. So again, these are conversations that I want to bring to you guys. I know they're not, they can be a little wordy, they can be a little biological, a little maybe perhaps hypermedical, but I do want you guys to understand this, and I want you guys to encourage you guys to ask questions so that you understand it better. So I understand this is a learning process for you guys. This is why we're doing these videos. One of the reasons I'm doing these videos is obviously because of a lot of our patients don't read very well because their eyes obviously aren't working, their vision loss has progressed. So I found rather than writing another book or another 2 or 3 books, it's probably more productive and easier to communicate with you guys through these videos so that you can understand and have a different way to process information. I know some of you guys read, that's why we send the emails out, you read a lot better, but the videos seem to be working really well in terms of communicating this information for you guys. We're getting a lot of feedback. So next session, we're going to talk about the how, right? How have we used these clinical strategies? What supplements, what lifestyle factors can we do to not only slow down this mitochondrial dysfunction process that can arise, but also what can you do? What supplements can you take? Diet, lifestyles, what therapeutic modalities do we use in clinic that I've developed over the last 25 years that'll help recover and preserve your vision long term? So that's what we're going to get into next time. Again, I am Dr. Andy Rosenfarb. Thank you for joining us. We are AccuVision Acupuncture, and your vision is our mission. Look forward to seeing you next time. Bye-bye.